Sorry about that. I accidentally hit the stop button when I was recording. I'm going to go ahead and pick up with number 8. Which expressions are equivalent to 13 to the 6th divided by 13 to the 8th times 13 to the negative 4th divided by 13 to the 2nd? I'm going to start with the top part of my problem. When I rewrite my problem, my 13 to the 6th is the same. But here, when I'm multiplying, so I add my exponents 8 plus negative 4, and I get 13 to the 4th power over 13 to the negative 2nd. Now, I'm going to go ahead and solve the division problem here. When I do that, I still have 13 to the 6th, but now I have 4 minus negative 2. When we do that, for subtraction problems, we keep change, so we keep the 4, change subtraction to addition, change a negative 2 to a positive 2. 4 plus 2 is 6, 13 to the 6th power. Now I'm dividing, so I'm going to subtract my exponents. 6 minus 6 is 0. I get 13 to the 0 power. Anything to the 0 power is 1, meaning we are looking for the answer choices where the answer is 1. So, looking at letter A, I have 1 over 13 to the 0 power. I know anything to the 0 power is 1, so it's 1 over 1. 1 divided by 1 is 1. A is a correct answer. Letter B, I have negative 1 to the 4th, so negative 1 times negative 1 times negative 1 times negative 1. We know that 2 negatives make a positive, so I can pair them up. 2 negatives here, 2 negatives here, 1 times 1 is 1. My answer is a positive 1. Letter B is a correct answer. For letter C, I have negative 1 7 times. And so again, I'm going to pair them up because 2 negatives make a positive. So 1, I got a set here and a set here. But I have an extra negative 1 out here to the side, and so that's going to end up being a negative 1 answer. So C is not correct. Letter D is 1 times 1, 13 times. 1 times 1 is 1. So D is a correct answer. Letter E, 1 over 13 to the negative 1st. Negative exponents means that we write them as a fraction. It's already written as a fraction, so E is not a correct answer. Number 9, 5c squared d to the 3rd times c to the 5th d divided by 40c to the 4th times cd to the 7th. First, I'm going to simplify the top, and then I'm going to simplify the bottom. So, starting with the top, c squared and c to the 5th, we're multiplying, so I add my exponent c to the 7th. D to the 3rd and D gives me D to the 4th, and then my coefficient of 5. On the bottom, I'm multiplying, so I'm going to add my exponents and get C to the 5th, because 4 plus 1 is 5. And then I have D to the 7th and my coefficient of 40, because those didn't change. From here, we can go ahead and simplify again. C to the 7th minus C to the 5th, because we're dividing, so we subtract the exponents and I get C squared. D to the 4th divided by D to the 7th gives me 4 minus 7, which is negative 3. So my problem is really D to the negative 3rd, but I know negative exponents have to go to the bottom, so I write them in the denominator. 5 can go into 40 8 times, and so 8 stays on the bottom as well. My answer is C squared over 8D to the 3rd. Number 10. 40 to the 8th divided by 4 squared raised to the negative 3rd divided by 4 to the 4th equals 4 to the n. What value of n makes the following equation true? So I'm going to start with raising to a power, and I notice that my problem becomes 4 to the 8th over 4 to the negative 6th. Because we are multiplying, when raising to a power, we multiply the exponents. 2 times negative 3 is negative 6. Now we're dividing, so I'm going to subtract my exponents. 8 minus negative 6. When we subtract, we have to keep change. So I keep the 8, I change subtraction to addition, and I change a negative 6 to a positive 6. 8 plus 6 gives me 14. So now my problem is 4 to the 14th divided by 4 to the 4th. We're dividing, so I subtract my exponents. 14 minus 4 is 10. 4 to the 10th power. N equals 10. And number 11, we are multiplying, so we're going to add our exponents. 4 plus 4 gives me 8, so a to the 8th. 8 plus 8 gives me 16, so c to the 16th. 9 plus 9 gives me 18, so e to the 18th. 3 times 3 gives me 9.